Exponent rules. Today we're learning how to multiply powers with the same base. Okay, same base means that, as you see here, a and a, that's my base. And the exponent is actually that small number written up above it. Here they're variables, but that little 2, that 4, the little teeny numbers written up above the base, we call that an exponent. And you should kind of know all about exponents by now. We're going to jump into what happens here. So a to the m times a to the nth power would give us what? I'm going to show the rule using nothing but variables. You want to write down the base. Because the base is the same, we can use this rule. That's the key part to this. You have to have the same base in order for this rule to work. If the base is different, then it will not work, and we'll get into that later in the video. But here I have a to the m times a to the nth, and I'm going to get a to the m plus n. You add your exponents together if the base is the same. And that's basically all there is to this rule. Bases are the same, you can add the exponents if we're multiplying. Okay, the next video that I'm going to be making is about division, and it's a whole different ballgame. But here we have 7 to the third power and 7 to the fifth power. My bases are the same, so I can add my exponents. 3 plus 5 gives me 8. My answer to this would be 7 to the 8th power. And down here, no different. 3.5 or 3.5 times 3.5. The bases are the same, so I am allowed to add my exponents. 2 plus 4 gives me a 6. 3.5 to the 6th power gives you your result. Now, you'll have a calculator on you at your desk. You just type that in, and you can break it down and simplify it to an actual number. Okay, but this is how you simplify expressions where you're multiplying powers with the same base. So let's do one more practice right now with variables. If I were to say y to the 5th times y squared, my y and y, they're the same base, y and y. It's not an x and a y. They're the same, both y's. So my result is y to the 7th power, because 5 plus 2 gives me a 7. All right, what if I were to throw a negative exponent in there? What would you do then? You would say, let's say x to the 4th times x to the negative 3rd. I want you to write out what that actually means. What that means is x to the 4 plus, you're adding these, 4 plus negative 3. You're adding a negative, so you're really subtracting. You would get x to the 1st power. It's important that I go over this right now, because x to the 1st power, you don't want to say, you don't want to write down the 1. You don't need to. There's no sense in it. X to the 1st power just means x. So no need to show that. Your result here would be x. That comes into play with what I'm about to show you. Now, where do these problems go? They're not going to be as simple as just take this, match them, add them up. We're going to get into algebra where we're asking you to do something more along the lines of this. 3 to the 3rd power, x to the 2nd power, y to the 5th, times 3 to the 2nd power, x to the, let's say, 4th power, y. When you have this problem, I want you to break it up into 3 completely separate parts. All right? We just got done doing problems where we just had a single base. Now you have an expression where we have bases that have 3 different parts to them. A 3, a whole number, an x, and a y. Break it up into those 3 parts. Do your 3's first. You have a base of 3, a base of 3. So we can use this rule and treat it like the x and y's aren't even there. 3 to the 3rd times 3 squared would be 3 to the 5th, based on what we've been talking about. So your answer here with this is going to be 3 to the 5th power, x squared, x to the 4th. The bases are the same, so we can just add that 2 and that 4 to get x to the 6th. And then last but not least, we have y to the 5th and y. We just got done talking about how when the variable is by itself, there's really a what above it. We just don't show it. There's a 1 right there. Just no need to write it down. So there is a 1 right here, and I will oftentimes see students say y to the 5th here at the end. We have y to the 5th. We have to add that invisible 1 to get y to the 6th. So I hope you guys understand why this is a 6 here, because there actually is a 1. It's just not going to be written down for you on a piece of paper or on an assignment. Okay. Hopefully that makes sense to you. 3 to the 5th power, we could now change that, simplify it down to one large number, which 3 times 3 is going to be 9. You're going to have another 81. 81 times 3 is going to be 243. 243, x to the 6th, y to the 6th. This would be our final result, the most simplified version of this expression. How to multiply powers with the same base, add your exponents. That's basically what it comes down to. And if you're not sure where that 243 came from, it's just saying 3 to the 5th power, which most of you probably, you're going to have a calculator out on your desk. Just type that in, 3 to the 5th power. It'll give you the result of 243. It's just 3 times 3 times 3 times 3, 5 times. All right, hopefully this all makes sense to you. You can now use it. You're going to be taught in my next video how to divide powers with the same base. So when you multiply powers with the same base, you add. Hint, hint, and what we're going to go into next, dividing powers with the same base, you're probably going to do an operation similar to adding but different. You're going to subtract. Tune into the next video where I can show you what that looks like and why it works, just like I did over here. Oh, I didn't really go into that, did I? Let's finish up with that. What is 7 to the 3rd power? It's just 7 times 7 times 7. If you want to understand the why of why this works, 7 to the 3rd power is just 7 times itself 3 times. 7 to the 5th power is 7 times 7 times 7 times 7 times 7, 5 times. How many total 7s do we see? Count them up. 1, 2, 3, 4, 5, 6, 7, 8. That is why you get 7 to the 8th power, and that is why this rule works. So hopefully all of this makes sense to you. You took notes on it. You did some practice problems with it. You're going to be asked to do this with much lengthier, trickier problems, more like this, and you will be prepared after watching this video. So see you guys on the next safari, and good luck.